In this lesson, we're going to look at the basic things that we have to know in integration, and we're also going to see use substitution, and we're going to do a lot of different type of examples. So let's get started. Well, the first thing or the first basic thing that you have to know when you consider integration is the constant numbers. So when you consider the constant numbers in derivative, all the constant numbers are zero. So we don't write it, or we don't care, we don't worry about the constant numbers when you counter the derivatives. But when you counter the integration, constant numbers also got a value. So as you guys can see over here, they are all our constant numbers. So the way that you deal with the constant numbers when you count the integration is, so to derive 4, to derive this one, you're gonna get 4x plus c. So the way you derive this 4 is gonna be 4x plus c. And when you count to the 5, it will be 5x plus c. And when you count to the 7, it will be 7x plus c. So this is how it goes. This is just a pattern that it just goes all the time. So if it is 20, it will be 20x plus c. If it is 100, it will be 100x plus c. So that's how it goes. That's how it goes when it comes to integrating the constant numbers. And the other basic thing that you have to know is this formula. So when you counter this formula, if you guys get a type of function that looks like this one, or it can be this one, or just this one, you're gonna use this formula to derive that type of function. So, and the way you derive it is you're gonna have to add 1 in the exponent or in this n. Exponent means this 7 or this negative 7, 4, and that's what an exponent is. So you're gonna have to add 1 in that exponent, and you're also gonna have to write the result that you get in your exponent down over here in your denominator. And then finally, you're gonna have to add it or add c. So that's the whole process that you have to do. So now let's just implement the formula, and let's just do some type of questions that we have to use the formula. So when it comes to this specific example, we gotta use this formula, and that's how we derive it. So, I mean, that's how we integrate it. This is not actually derivative, this is integration. So the way that I'm gonna integrate this one is I'm just gonna say x the whole. So as you guys can see over here, it says n plus 1. So I'm gonna add 1. So I'm gonna add 1. So it will be 7 plus 1 will be 8. And then I'm also gonna have to write my result, or this 8, down in my denominator. So it will be 8, and then plus c. So this is all you have to do when you count to this specific example. And when you count to the x raised to the negative 4, don't forget that we're gonna add, not subtract. Subtraction is for derivative, so we're gonna have to add when you count to the integration. So I'm just gonna add 1, so plus 1. So x negative 4 plus 1 will be negative 3. And then I'm also gonna have to write this negative 3 down, and then plus c. So this is all you have to do when you count to this type of functions. And then when you come to this one is actually the special one, because in integration, this, or the way you integrate this one, is different. If you remember, in derivative, you're gonna have to multiply 5 by 3. It will be 15x raised to the 4, and then subtract 1, and it become 4. But when you come to this one, you don't have to worry about the thing that's found, or that's in front. Just don't worry about this. All you have to worry about is just the exponent. You're gonna have to remember that. When you come to the integration, just don't worry about the thing that's found in front. So I'm just gonna say, so the way I'm gonna derive it, that I'm gonna integrate this one will be, it will be 3x raised to 5 plus 1 would be 6. And then just do with this, just in this type of form. So it will be 3x raised to the 6, the whole over. I'm going to have to write my result down in my denominator's part, and it become c. So this will be my result. So just don't care about, or don't worry about this one. Just, try to just integrate this part, just this specific part. That's how you integrate it when you encounter this type of functions. So now the last one will be, the last one is actually the same as this one, is the same as this one. So I'm just gonna add and do the whole process. So when I add 1, and then I'm also gonna have to write my result down on my denominator. So this will be what it will be, x raised to, when you add 1 in negative 3 over 5, you're gonna get positive 2 over 5, and then the whole over positive 2 over 5. And then I'm gonna flip it to just simplify. So when I'm gonna flip this two thing, or the thing that's found in my denominator, I'm gonna get 5 over 2x raised to the 2 over 5. And then this will be my last answer. So this is all you have to do. Just try to memorize or just try to understand the pattern that goes all the time. Just you gotta know this thing all the time. You're gonna have to add 1 when you come to the integration. So it's not the same as derivative. You don't subtract over here. Just you gotta add. You're just gonna add all the time. And when you come to these constant numbers, just remember that it's not zero. It's not the same as derivative. I mean, it's not the same as derivative yet. When you come to the integration, you just gotta, do it this way. So that's the main thing you have to know. Now let's do some type of use substitution questions, and let's do it. Okay, so when you come to this example, it says 3x plus 3 the whole power of 8. So I'm going to use a u substitution, and I'm going to integrate this function. So I'm going to say that u is equal to 3x plus 2. So I'm just substituting this 3x plus 2 by u. So this will be u raised to the 8th. And then I'm going to say du is equal to, now I'm looking for this dx, so I'm trying to find the dx. So du is equal to, when you integrate 3x plus 2, you're going to get 3 dx. So when my value of dx will be over 3 and then over 3. So dx will equal to du times by, or du over 3. So I'm going to say u to the 8 times by du over 3. And then I want to bring this 3 to the front. So for that reason, this will be 1 over 3 and u to the 8th and plus c. So now what I want to do is just I want to integrate this part. So when I integrate this part, this whole thing will be 1 over 3 u to the 9, because that's adding, so u to the 9, and then the whole over 9 plus c. So now I'm just gonna write this 3x plus 2 instead of u. So I'm gonna say 1 over 3 the whole 3x plus 2 the whole the power of 9 over 9 and plus c. So let me just write, it will be plus c actually, so just let me write my last answer over here. So when you just multiply 1 by 3x plus 2 the whole the power of 9, you're gonna get 3x plus 2 the whole the power of 9. And when you multiply 3 by 9, you're gonna get 27. So it will be 3x plus 2 the whole the power of 9 over 27 plus c. So this will be your last answer. So this is all you have to do when you come to this specific example. So as you guys have seen, it's just the easy process. Just try to follow this process and you're gonna do it. So now let's just add some other function, some other examples. So now I want you guys to stop the video and try this example. This is easy and this is also the same as the previous one. So you're gonna do it. So I'm just going to say u equals to 2x minus 5. And then du is equal to, now I'm looking for dx. So du is equal to, when you derivative it, you're going to get 2 dx. And then the whole over 2 and the whole over 2. And then I'm going to cancel these two things and I'm going to get, actually, this is u raised to the 10. So times by my dx value is du over 2. So now I'm going to bring this 2 to the front, so it will be 1 over 2 u to the 10 plus c. Now I want to integrate this part. So when I integrate that part, it will be 1 over 2 u to the 1 plus 10, it will be 11, and then the whole over 11 plus c. And then now I just want to write this 2x minus 5 instead of u, so it will be 2x minus 5 the whole to the power of 11 and the whole over 11 plus c. So this one is plus c. So now let me just write the last answer over here. So it will be, when you just multiply 1 by 2x minus 5, you're gonna get 2x minus 5 the whole to the power of 11. And when you multiply 2 by 11, you're gonna get 22, and then it will be plus c. So this will be your last answer. So this is it. This is the easy process, and I hope you guys have done it and you guys have get the answer. This is the right answer. So this is the, all you have to do. So now let's add one last example that's a little bit different than this type of examples that we've been doing. So now I want you guys to stop the video and try this one too. This is also the same and easy. You know, there's just a little difference, but it's just easy one. So I'm gonna just follow the same process. I'm gonna say u equals to 3x minus 1, and I'm gonna say u raised to the 3. So when I derivate this thing, I'm gonna get du equals to 3 dx. So I'm looking for dx, so the whole over 3 and the whole over 3. And I'm gonna multiply this by the du over 3. But I also got this 5 over here in this specific example. So I'm just gonna bring this thing to the front. So when I bring it to the front, I'm gonna get 5 over 3. So, and then now, this will be u to the 3 plus c. Now I want to integrate this part. So when I integrate that part, it will be 5 over 3, the whole u. So 3 plus 1 is 4 over 4, and plus c. And then now lastly, what I want to do is I just want to write this 3x minus 1 instead of u. And then it will be, and then lastly, I'm just going to multiply this 3 by 4, and then it will be 12. So this is it, and this is all you have to do. And lastly, just don't forget to add this c. So it seems like we're done. So this is all you have to do when it comes to this question, and this is the whole thing you gotta do when you guys are using this u substitution. Actually, I also got another video on this u substitution, specifically on u substitution. And I've done a lot of different examples that involves exponential function, that involves, just trig functions and square root functions in that video. So I want you guys to check that video and get benefited from that. But just for introduction, this is what a u substitution is all about. So this is it for this video, and thanks for watching, and have a good day.